So what we're doing here is we're just simply trying to find a quadratic function based on the zeros and a little bit more information that might be available. And after that, we're also going to try to see if we can put that same equation into standard form. So let's start off by looking at a function that has two zeros. One is at 5 and one is at 1. I'm going to mark that off on this grid, on this grid right now. So one of the zeros is at 1. The other one is at 5. So that's 2, 3, 4, 5. So somewhere around here. Could we come up with a parabola that goes through those 2 points? Well, yeah, that's not too hard. I could draw a parabola that looks maybe like this. But is that the only parabola that could go through those two zeros? The answer is no. I could actually draw one that opens down as well, going through the exact same 2 points. And the truth is, I could even draw one that opens up, but doesn't match the red graph that's there. In other words, I could draw one that looks maybe a little bit wider than the first one. So that means that there are several different graphs that we can draw that go through those 2 points. There isn't one specific graph. And the question is, can we nail it down to a particular graph if we have some more information? The answer is, of course, yes. So on the next page, we see that we do have some more information. We have that the point 46 is on the graph. Can we use that information to get the specific graph that goes through those 2 points? All right, recall in grade 10, you did something called factored form of an equation, of a quadratic equation, that is. It looks something like this, where you had an unknown a, then you had x minus the zeros. Let's call the zeros 0, 1 and 0, 2. All right, so those are my two zeros. And in this case, for the two zeros that we have, that would therefore be a x minus 1. We said that was one of the zeros from the previous page. And x minus 5. That was the other zero we talked about. But then we said we didn't know what the a was. But we now have this 0.46 on it, which should help us to figure out what this a is. So what I'm going to do is I'm going to put in 6 as my y. That's my y coordinate. And I'm going to put in 4 as my x and see if we can narrow down this a. So therefore, let's see, that would be 6 equals a. We don't know what the a is yet. But then 4 minus 1 and 4 minus 5. Okay, so let's see if we can finish this up here. This, of course, would be 3, and this would be minus 1. That's 6. So this looks like minus 3a is equal to 6. And that obviously means that a is equal to minus 2. A is equal to minus 2. All right, so what is the equation then? Well, the equation now becomes y equals the minus 2 that we just got, x minus 1, and x minus 5. They ask us to put this in standard form. Well, remember, standard form looks like this. Y equals ax squared plus bx. If we had to use the quadratic formula, we'd have to have it in standard form. So here's what standard form looks like, if you remember. The a, the b, and the c are what you'd find in your quadratic formula. We did that yesterday. So how can I make this equation, which is in factored form, look like this equation, which is in standard form? Well, that's not too hard. We could multiply out or expand these two binomials. So let's see. Let's remember FOIL. So I'm going to x minus 1, x minus 5. I'm going to FOIL those two brackets. All right. So that would give me the minus 2 is still there. We'll get to that later on. So it'll be x times the x, which is x squared, x times the minus 5, which is minus 5x, the minus 1 times the x, minus x, and the minus 1 times the minus 5, of course, is the plus 5. Okay, then we close up our brackets, and then we can expand that a little bit more. So minus 2x squared plus 10x plus x. Oh, I'm not writing that right at all. That's plus 2x. Let me correct that. Let me quickly correct that. All right. So it's the minus 2 times the minus 5, which is a plus 10x. Okay, that part's right. And then we're multiplying the minus 2 times the minus x, so that would be plus 2x. And then, of course, the minus 2 times the 5, which is minus 10. And a little bit of tidying up now. So minus 2x squared plus 12x minus 10 would be our standard form. So now if we had to put this into the quadratic formula, we're ready to go. We have our a, our b, and our c. And we could figure out what the x values are. I mean, we already know what the x values are, where the zeros are, because that was how we started off up here. But it's in standard form, so we could also use a quadratic formula. Okay, well, let's do another example like that one, where they give us two zeros at plus and minus 2 and tell us that one of the points on the graph is at 0, 3. This looks like it would be the y-intercept, because if my x value is 0, then that 3 sounds like it would be the y-intercept. All right, so let's, again, put this into that factored form we just did. So y equals a. We have plus 2 and minus 2, so it's going to be x minus 2. So minus the 2 that we have here, and then we're going to minus the minus 2, which of course is plus 2. And again, we need to figure out the a. So we have the 0, 3. We're going to put in 0 for x and 3 for y. So here's my y value of 3. And then I'm going to put 0 minus 2 and 0 plus 2. Seems simple enough. Of course, if it's 0, it simply means that I'm going to have minus 2 and plus 2, which is equal to the 3. And therefore, minus 4a is equal to 3. And then that simply means that a is minus 3 over 4. So my equation, first of all, put it in factored form, and then we'll change it into standard form afterwards. So in factored form, it would be the y equals the minus 3 over 4. We just figured out what the a was. Then we have the x plus 2 and x minus 2. Now, the x plus 2, x minus 2, that should kind of trigger something in your mind, because this looks like we had a difference of squares, and then we squared it. That's why we got x plus 2 and x minus 2. So the truth is, I could actually multiply this out without going through the whole long process of using FOIL, because that would end up being, if you sort of stay with me here, x squared minus 4. Think of what would happen if I had x squared minus 4 and I had to factor it. I would end up with the x plus 2 and the x minus 2. So the opposite is obviously true, that x plus 2, x minus 2 is x squared minus 4. So all I'm going to do now is multiply this out. So it goes into standard form. So I'm going to expand or distribute the minus 3 over 4 into this. So minus 3 over 4 x squared minus 4 times minus 3 over 4. Okay, a little bit of tidying up now is all we need to do. So y equals, okay, the minus 3 over 4 x squared doesn't change. But if I multiply these two together, one is negative and the other is negative, I'm going to get a positive. If you put that over 1 to sort of see what's going on here, I'm going to end up with just simply plus 3. And that answer makes sense because that plus 3 would be my y-intercept. And this point that we got earlier on is in fact a y-intercept. So the minus 3 over 4 x squared plus 3 from that point of view makes absolute sense. Okay, so let's do this one other example here, similar to the one that we just did, where they now use language that we may not have heard before. They call this thing a double zero. A double zero at x equals minus 2. And it's a very simple explanation. A double zero just simply means that both zeros are the same, which means that this graph, this parabola, only touches the x-axis at one spot. And that spot, of course, would be the vertex, which we talked about a couple of days ago. So how do I represent that in factored form? It's only 1, 0, and that 0 is at minus 2. Okay, let's see if we can do that. So y equals a. And because it's a minus 2, we're going to say x plus 2. And it's a double zero, so there's another one at x plus 2. But then if we're multiplying two brackets that are the same, then we could just say we're squaring it. So we'll just write it that way. A x plus 2 all squared. And this one has the point 3, 10 in it. So we'll do what we did in the last example. We're going to plug in the 3 as the x and plug in the 10 as the y and see what happens to get the a. So 10 equals a. We don't know the a yet. And that's going to be 3 for the x plus 2 squared. All right. Remember, that's the same bracket being multiplied by itself. So we're just saying 3 plus 2 squared. And that, of course, is 5 squared, or 25. So 25a equals 10. And if I just divide through, then my a is equal to 10 over 25. And of course, we should always reduce our fractions down as much as possible. Dividing both by 5 gives me 2 over 5. So I'm now ready to write my equation because I have my a. So y equals a x plus 2 squared. Well, we have the a. Why am I saying a? We should just write the a in. No longer just a, but 2 over 5. Okay? And there you go. That's your equation. Now, if I wanted to put this in standard form, like the question requests, let me undo that. If I wanted to put this in standard form, like the question asked us, then we just simply go ahead and square this bracket. And I'm going to remind you that when you square a bracket, a binomial that is, you square the first term, so in this case, that's x squared. If we don't have to go through the whole long process, we went through this a few days ago, square the first term, multiply these two terms together and double it. So these two terms together will be 2x, so that's 2x times 2, which is 4x. And then we square the last term, which is 4. All right, so we can go ahead now and finish that up by multiplying that, distributing that 2 over 5 into the bracket. So it's 2 over 5x squared plus, since this is 4, I'm going to multiply the 4 by 2 over 5. It's going to be 8 over 5x. And the same thing would happen with the other 4. 4 times 2 is 8 plus 8 over 5. There's your standard form. Okay. All right. So I'd like us to try to apply this to a word problem. Now, if we're trying to solve a word problem, there are some steps here. I'm not going to read them out to you. You can read them on your own later on. But we're going to see if we can take a real life situation and apply this kind of principle to it, where we know some of the points on the graph and we're trying to come up with the equation of the graph and perhaps even use that to get some features of the graph. Let's see what this looks like. I won't do the whole question because in class we only got to a certain part, so we'll only stop at the part that we got to in class. Parabolic opening to a tunnel is 24 meters wide. So if you're measuring along the ground, it's 24 meters wide. And that's from one side of the parabola where it meets the ground to the other side where it meets the ground. They're also telling us something else about this parabola, about the parabolic shape of this tunnel. At the point that's 3 meters from each side, the tunnel is 6 meters high. I wonder if we can put that into some kind of a picture. I'm going to put along the ground here, right, a line to represent the base of the tunnel, and then an arch to represent the path of the tunnel as it goes up and comes back down. And that's parabolic, right? That's a parabola. We were told that they were 24 meters apart. That's where the tunnel hits the ground. So here and here, these 2 points are 24 meters apart. So from here to here, it's 24 meters. And the other thing we're told is that if you go 3 meters in from each edge, I'll show you where it says that in the question. At the points that are 3 meters from each side, the tunnel is 6 meters high. So if I move from one edge, like this edge right here, and go in 3 meters, so let's say approximately right there, so let's say this is 3 meters here, that the height of the tunnel is, I should probably put that in a dotted line, make it a little more obvious. So if I, let's use this thing here. If I put a dotted line here, this would be 6 meters high. Let me go back to this. This would be 6 meters here and 3 meters going this way. So 6 meters up and 3 meters going along the ground. So you're 3 meters from the edge. And when you go 3 meters along the edge, you can go 6 meters up in the sky. Okay, I want you to think about this as if this was sitting on a coordinate plane, like an XY axis. And I'm going to put those two in as dotted lines right now. So let's say that this is my y-axis and this is my x-axis. And I'm going to put one edge of the tunnel right on the origin. And of course, the other edge of the tunnel would be sitting somewhere along this 24-meter x-axis. I want you to try to think of what those coordinates might be. What coordinate would I have here? I've kind of given it away already by saying it's at the origin. And what coordinate would I have here where it hits the edge of the tunnel? Well, obviously, if I'm at the origin, one point on the line, so a point on the line would be at the origin of 0, 0. But how about the second point over here? It's 24 meters along the x-axis, but sitting still on the x-axis. Wouldn't that also be 24, 0? Right? That would be almost like you're just simply moving along the x-axis and sitting right there so that the y-coordinate is still 0, but your x-coordinate is 24. One more point. How about this point that's sitting up here on the edge of the parabola? What kind of coordinate would that look like? Well, I'm 3 along here and I'm 6 along here. That's my x-coordinate. That's my y-coordinate. That's 3, 6. So there is my third point. Now, we were using factored form a few minutes ago, where we had the two zeros. Do we have zeros here? Well, we do, because 0, 0 is one of the zeros, and so is 24, 0. So we can actually write the equation as a x minus 0. Truth is, x minus 0 is still x. You're minusing 0 from something, you haven't really changed its value. And then x minus 24. So that represents the sort of generic equation, but we can be more specific because we were told that there was this 0.36 that was on the graph. So we can do the same thing we just did a few minutes ago. We can put that 3 and that 6 as my x and my y. Okay, so let's put this as 6 for the y is equal to a. 3, I'm not going to put minus 0 because minus 0 doesn't change anything. And then 3 minus 24. Okay, that looks easy enough. So this looks like a 3 and is that 21 or minus 21, I guess, is equal to 6. And how about if we, okay, let's do this. Let's divide both sides of this equation by 3. All right, so if we did that, then we'd have minus 21a is equal to 2. 3 divided by 6 is 2. And therefore a is equal to, let's say, minus 2 over 21. Now, hopefully that doesn't surprise you that this is negative. It should be negative because this parabola is turned down. So what is the equation of the parabola? Well, we have the a, so we can write the parabola equation. It should be y equals minus 2 over 21 x. I'm not going to put minus 0 anymore because that's hopefully obvious. And then in the other bracket, we're going to have x minus 24. That represents my function. Right? If I put this on Desmos, it should go 24 along the x-axis, the distance between the two zeros, and it should also go through the point 36, if I'm right. And you can try that on Desmos when you have some time. We're going to try to answer one more question, and then we'll wrap it up. Find the maximum height of the tunnel. Well, I'm thinking, okay, we know that for a parabola, the maximum usually occurs right in the center between the two zeros. We have our two zeros. There's one here, there's one here. The middle of these two would be a 12. So why don't we figure out, so it tells me that the axis symmetry for this function is at 12. If I put that 12 into this function and get my y value, that should be my max height. That should be how high up it goes along the y-axis, which is the max height of this tunnel. So we'll do that. We'll say that y equals, so this is for the max height that we're trying to figure out now, for max height. So y equals minus 2 over 21. The x that we're using, we said, was 12. And then the x again is 12, so 12 minus 24. Okay. So let's do a little math here. So y equals minus 2 over 21 times, let's say 144, minus 144. Why am I saying minus 144? Because this is going to be minus 12 that comes out to this, times this other 12, which of course is a product of 144. And it's negative because the 12 minus 24 is negative. So by some mental math, this would be a positive number, 288 over 21. Now I'm going to leave it in that form. I mean, you could always grab a calculator and get some decimal number from this, but I'm ready to write my statement. I'm going to leave it in exactly that form. So the max height of this tunnel, giving you a formal statement here. I should spell tunnel right, is 288 over 21 meters high. Whatever that is, and again, I should spell that right too. Let's try that again. Oh, yeah, actually, that was the correct spelling. All right. And that is all she wrote. Just to make a little last minute edit here. That is the height of the tunnel in meters.